Hello students. In this video, we are going to see the Unit 5, that is Lattice and Boolean Algebra concepts. First, in this video, we will see the lattice first. Partially ordered set, and what about the assay diagram? First, we will see some of the applications. Lattice is designed to have a wide range in cryptography, especially in encryptions. We have so many encryptions like public key and key leakage attacks and identity based, like this. So many applications are there. First, we'll see that what is a partially ordered set. Partial ordering set, another way we can pronounce like that. Reflexive, transitive, and anti-symmetric. If these three conditions is satisfied in a set, then we call that as a partial ordered set. First, we'll see the partially ordered set. Definition: a relation R on a set, we call it as partial ordered set, if it satisfies the three conditions: reflexive condition, anti-symmetric condition, and transitivity condition. It is simply call it as poset. It is denoted by p comma less than or equal to. It's not actually a less than symbol. We call this as a binary operation. We see some of the examples. Let A be the collection of subsets of S. So S is a superset and A is a subset. So we can say the relation it is contained. Similarly, if you are taking a Z plus positive integers, each and every number in that set is greater than 2 other. So we call this as a greater than or equal to. We will see the Hasse diagram definition. Hasse diagram means it's a pictorial representation of poset. We consider an example. A set contains two elements A, B. So how can we write a Hasse diagram for this? Here the relation is contained. So first we write a power set for this set. Empty set, singleton set AB, then AB together. For this, we'll draw the diagram. So first started with empty set, because empty set is the set contained, contains all, contained in all A, B. So then we have a relation between this empty set with A and empty set with B. Now if you combine this AB, then we draw the lines between these two, and AB is a set contains all these three, A, B, and also empty set. We will see another thing. Three elements are there, A, B, C. If I am having a three elements in my set, then first we try to write the power set. Start with the empty set, then singleton A, B, C, then two elements together A, B, A, C, B, C, and all the three together. So if you are writing that contained here, first empty set only is contained in all the singleton set first. So you may draw the line A is having a relation between A and empty set, and B and C. Now you combine this A and B together. Here we got two elements in a set AB. Similarly AC, BC, and all the three together gives ABC. Now we'll see the comparable. What is the meaning of comparable? Comparable is very easier to understand. If I'm having any relation between that elements, then we call it as it's a comparable. For example, the relation is divisibility. If I am choosing, is 2 is divided by 7? No. If 7 is divided by 2? No. If it is divisible, we can choose that is a comparable. If it is not divisible, then that meaning is not comparable. Next, we talk about greatest element and least element. We understood that in the set, if it is a greatest, we call that as a greatest element. In the set, any element is least, we call that as a least element. In another word, we are going to use that in lattice. I should know what is the greatest element and least element to find the lattice. What is the meaning of lattice? Lattice is a four set, first of all, in which every pair of elements have both greatest lower bound and least upper bound. GLB and LUB is the short form of that. Let us see what is the definition for GLB. GLB of any two elements, if I am choosing that, we can write that as A asterisk B. In another word, we can say this is A meet B or A product B. In LUB, we have to say that is LUB of A comma B is nothing but A plus B or A join B, or you can use a word just plus also. Lattice is denoted by triple binary operator. It may be L asterisk and with plus, or L dot with plus, or L meet and join together. So three together we call it as a lattice. We'll see some example of this. Instead of, if you are having a number, instead of taking this GLB and LUB, we have another option also. LUB is nothing but LCM. GLB is nothing but GCD. Easily you can remember using the definition of this. We will see some number. D20. D20 is a divisor. What are the elements divides 20? First we take 1 divides, 2 divides, 4, 5, 10, 20. All these are divides. So these are, everything is a comparable. We put a Hasse diagram. Start with the least element 1. And we take two elements. 2 is the next element. We have a relation between 1 and 2 because 2 is divisible by 1. And we take 5. 5 is divisible by 1, but 2 is not divides 5, 5 is not divides 2. So 2 and 5 are incomparable, 1 and 2 are comparable, 5 and 1 are comparable. So again we choose the next element in the set 10. One more thing is there 4. So we just take this 4 above the 2 to the next level because we have a relation between 4 and 2. And we take the next 10 element above the 5 because 5 divides 10 and also 10 is divisible by 2. So we draw a line between this. Now 20 is the greatest element that taken to the next level, and we have a relation divisibility between 20 and 4 and 20 and 10. Similarly, we can draw the Hasse diagram for D30 also. Now we can say D20 is a lattice. Thank you students for watching this video.